All right, so 7.4, we're looking at examples where we have fractions in the exponents and converting those to radicals and vice versa. So when you have a fraction exponent, so looking here, you have a to the m over n power. This is the nth root. So your denominator of the fraction tells you what type of root it is to raise to the nth power. So what that looks like, if our goal is to convert it to a radical, the denominator is the root. So it's the nth root of a raised to the m power. So the number on the bottom is the root that it is. The number on the top is the exponent that a has. So for example, number 1, I have x to the 1/4 power. That is the same thing as having the 4th root of x raised to the 1st power, which is just the 4th root of x. So if I look at that in my calculator, if I do 10 to the 1/4 power, I get that. Or if I do the 4th root of 10 to the 1st power, which is really just 10, you get the same thing. Those just two different ways of writing the same thing. And sometimes, depending on what type of problem that we're solving, you might need it in one or the other forms. Okay. So number 2, what type of root do I have? A square root. Now you don't need to put the 2. When you have a 2, you don't really have to put that. So it's just a square root of 15x raised to the 1st power. So really you don't even need to write that 1. So it's a square root of 15x. What type of root do I have on number 3? A what? A cubed root. So the 3rd root of 24 raised to the 1st power. So number 4, I have the cubed root again of 7. What is the exponent with the 7? 2. And if you can simplify these, go ahead and do that. Do we know what 7 squared is? 49. So this is really the cubed root of 49. And let's go back to number 3. We can actually simplify this one down. I didn't think about that. So 24, a cube root of 24, is there a perfect cube that goes into 24? 8 does, yes. So actually we need to break this down into the cube root of 8 times the cube root of 3. What is the cube root of 8? 2. So 2 cubed root of 3 is our final answer on that. Is there a perfect cube that goes into 49? There's not. 1, 8, 27, those don't go into 49. All right, number 5, we have what root? The square root of x to the 7th. Can we break this one down? We actually can. Because remember, we just want an exponent that is a multiple of 2. So if I take out one of the x's, I'm left with x to the 6th, which is a multiple of 2. And what is the square root of x to the 6th? X cubed. So x cubed square root of x. And be very careful when you're writing these. When you write this 3, make sure it's spaced away from the square root. You don't want it to look like the cube root. Just be very careful. Sometimes if you want to write a multiplication symbol in between there to make it a little bit more obvious, you can do that. Number 6, what type of root do we have? Fourth root of 3 to the 5th power. Well, what is 3 to the 5th power? It's 243. We need to see if there are any perfect fourths that go into 243. If we divide by 81, we get 3. So this is, I have the fourth root of 81, fourth root of 3, because 81 times 3 is 243. What is the fourth root of 81? 3. So this is 3, fourth root of 3. And you can always check your answers. You know, if we do 3 to the 5/4 power, and we check the fourth root of 243, yep, same thing. 3 times the fourth root of 3, also the same. But this one is the most simplified version. So if your question says that you have to simplify it, you have to give this answer. The fourth root of 243 is not a correct answer because it's not completely simplified. All right, number 7. We have the fourth root of xy to the 3rd power. You could also write this as the fourth root of x cubed y cubed. I think either one of those would be correct. There's no way to remove any x's or y's to get an exponent that's a multiple of 4. So that means that you can't simplify it any more than that. So just be aware that these two are the same. That's using exponent rules here. So if you have like a multiple choice question, you need to be able to identify both of those. All right, number 8, what root do we have? This is the cubed root of negative 6x squared. Which is the cubed root of, what's negative 6 squared? 36x squared. Are there any perfect cubes that go into 36? 1, 8, 27. 8 does not go into 36. So no. So this is completely simplified. And the x squared, you can't remove any x's to have an exponent, a multiple of 3. Because your original exponent is less than 3. So you can't do that. Number 9, we would have the 7 times, the 7 is on the outside. That 7 does not have the exponent of 1/2. So it's being multiplied. So 7 times, and then we have the square root of 12x. Is there a perfect square that will go into 12? 4. So I'm going to break this one down. 4, and then I'm left with 3x. What is the square root of 4? 2. So 7 times 2 is 14. Square root of 3x. Any questions? And this will just take some practice. Sometimes if it's been a while, you forget if the top or the bottom is your root, so you just kind of have to memorize that. Now, converting, if I give you a radical and you are converting it to exponential, so you're giving the exponent, sometimes those seem to be a little bit easier. A lot of times there's not as many simplifying problems that you have to do. So looking at number 10, I have 16. It's the cubed root of 16. So what exponent should I give this 16? 1/3. Good. Okay. Number 11, I have the square root of xy. Couple ways you could write this answer. Any ideas? Xy to the 1/2 is probably what I would do. You could also do x to the 1/2, y to the 1/2. I guess would technically be the same thing, but I would just do it like this. Okay. Number 12. What are we thinking on this one? 8W. Yep, 8W to the 1/4. Again, if you're not certain on your answer, type something in with this problem and type something in with the answer that you have wrote down to see if they have the same decimal value. Number 13. We would have what?
11 to the 2/3.
Perfect. 11 to the 2/3. Now you'll notice on 11 and 12, I did put these things in parentheses because you have an x and a y. If I don't put the parentheses here, it would look like I'm doing x times y to the 1/2. When there's just an 11, you could put that in parentheses, but you don't necessarily have to. But like when you've got a number or two variables, you definitely need to put that in parentheses. Number 14. Any ideas on this one?
X to the 5/4.
Yep. X to the 5/4. Now, number 15 is a little different. We have the square root of 3m, and that whole thing is raised to the 7th power. We only want to give one exponent in our answer. So we first need to do what's in the parentheses. So how would I write this one? 3m to the 1/2 power, and then I've got a 7 exponent on the outside. Do you remember your exponent rules? What do I do with these two numbers? Multiply them. So if I multiply a 1/2 times 7, that's just 7 over 2. So 3m to the 7 over 2 power. If we look here, 1/2 times 7, oops, is 7 over 2. And if you want to check this, If we do the square root, I'm just going to put 3x. I have no idea, actually. I better store a number for x, because if I had a negative number in there for x, it'd give me an error. So if I do square root of 3x raised to the 7th power, and then I do 3x raised to the 7 over 2 power, get the same thing. So that tells me that my answer was correct. Number 16 is very similar. We have a 4th root on the inside. So I'm going to have negative 2x to the 1/4 power. All of that is raised to the 5th power. And so how would that be if I simplify that? What would my outside exponent be?
Negative 2x 5/4.
Negative 2x, and then I have 5 over 4 outside. Good. Number 17. I got 10x cubed y to the 1/2 power. That was an easy one. And then over here, we've got 9x to the 7th, y to the 4th, to the 1/3 power. Any questions? Got a few more problems. And these all are going to require you to use exponent rules. So whenever we are multiplying, dividing, or raising to a power, that's what we're looking at now. We want to start with our problems in exponential form, meaning we have fractions as our exponents instead of having radicals. And then we use our exponent rules and we simplify, and our final answer we want to write as a radical. So we're going to start with exponents and get everything combined and then put it as a radical. So number 19, we have exponents to start with. It's in exponential form. When you are multiplying, what are you supposed to do with the exponents? What does that exponent rule say to do? Add them. When you are multiplying variables, you add the exponents. 1/3 and 4/3. Can you add those easily? Yep. If you don't know, use your calculator. 1/3 plus 4/3 is 5/3. So this would be x to the 5/3 power. And then how do I write that in radical form? Cubed root of x to the 5th. Perfect. No, I'm not done yet. Why am I not done yet? We can simplify it. Yep. This will be another thing that'll get you, because not that you're doing anything wrong, you just forget to do that final step. How many x's, if I want to split this up, how many x's do I need to move out? 2. Move out my x squared, which leaves me with x cubed. And what is the cubed root of x cubed? So we have x times the cube root of x squared. And now it's simplified. I'm going to highlight this where it says simplest. Number 20, I have x to the 2/5 raised to the 3/2 power. When we are raising an exponent to an exponent, what do I do with those two? Multiply them. So you can use your calculator if you need to. 2/5 times 3/2 is 3/5. So this would be x to the 3/5. And how do I write that in radical form? Yes, 5th root of x to the 3rd. Now this one, can I break this one down at all? No, because my exponent inside is actually smaller than my root. So I could not move out any x's and get a multiple of 5. So this one is simplified. Number 21. What about when I'm dividing variables? What do I do with those exponents? Subtract them. So 5/2 minus 7/4. Now, if you did not have a calculator, in order to subtract these, you would have to get a common denominator. But as long as you use your calculator, don't worry about that. We would have x to the 3/4. It's the wrong color. And how do I write that as a radical? 4th root of x cubed. Can I move out any x's to keep an exponent that's a multiple of 4? No, so we're done. And number 22, I do not have my problem listed or written in exponential form. So we have to do that before we can do anything else. So this would be x to the what power? 1/3 times x to the 1/2. Good. And when I'm multiplying variables, what do I do with the exponents? Add them. 1/3 plus 1/2 is 5/6. So x to the 5/6. And this is the 6th root of x to the 5th. Two more problems and then we're done. This one you can't split it up because I couldn't take away any of these x's and still have a multiple of 6. Number 23. This would be x to the 4/3 because it's the 4th power cube root divided by x to the 1/2. And when we're dividing variables, you subtract the exponents. And we get x to the 5/6 power again. Which again cannot be simplified. And last question, number 24. How would we rewrite the fifth root of x squared? X to the 2/5 raised to the 1/3. So what do we need to do with those exponents? Multiply them. And we get x to the 2/15, which is the 15th root of x squared. And can't take out any x's and have a multiple of 15. And that is all for this lesson.